The things I talk about are always things that were kind of difficult for me to wrap my head around, but became very important to me as a developer. And asynchronous programming is one of those topics. And this really kind of struck me when Windows 8 came out, because then we had store apps and portable class libraries and all that other fun stuff. And the thing is, if you went into Visual Studio and you said, OK, give me a new Windows Store app, it would have like async and await kind of sprinkled through the code. And if you don't know what's going on, you're kind of like, well, what is this? I guess I'll kind of copy and paste and maybe tweak a few things and cross my fingers and hope that it works, because it does look like magic. Well, it turns out that await is really just a wrapper around task. And so tonight we're going to look at both of those so that we can see what's going on. Because there's some places where we're not allowed to use await. But if we want to do asynchronous programming, we can still use task directly. So we're basically going to look at how to consume an asynchronous method using both task and await so that we can kind of get a good handle on what's going on there. And hopefully it'll make more sense. And I'm going to give you some shortcuts of things that stumped me along the way. So I want to start out just by a little history lesson. And this has to do with the asynchronous programming models that we've had in the past. Or the asynchronous patterns, I should say. The first of which was kind of the asynchronous programming model. Then we kind of moved into the event asynchronous pattern, and then we moved into the task asynchronous pattern. So, and these all had kind of their pros and cons, and things have gotten easier and harder along the way, which is both good and bad. So let's just take a quick look at those. So for those of you who have been doing .NET long enough to remember the asynchronous programming model, for this was method-based, and we usually had a pair of methods, one called begin something and one called end something. And the begin method would return this iasync result that we would then pass as a parameter to the end method. And you could do some basic stuff with this, but it was a little complicated. And in fact, every time I did it, I would have to look up how to do it, because it would never stick in my brain of, OK, how do I deal with this iasync result again? I don't know. Well, things got easier as we moved along to the event asynchronous pattern. And the idea behind this is that this has a method and an event. So to kick off our asynchronous process, we would just call this method that might be called something like getDataAsync. And then we would have an event that we would hook up an event handler to. As soon as that asynchronous process was done, that event would fire. The great thing about this was it was really, really easy to use, because hooking up an event handler is one of the first things you learn when you say, oh, I want this button to do something, right? So pretty much everyone can hook up an event handler. And then if we did get data back from that asynchronous process, it would usually come back in the event args. So it'd be some kind of custom event args that we could grab something out of. So the great thing about this was it was really easy to use. The bad thing is it was kind of limited in what we could do with it, because we basically can fire off a method and wait for the event to come back. And that's really all we could do with it. Well, then in the .NET 4.0 timeframe, we ended up with the task asynchronous pattern, which, as you can imagine, is task-based. And in this case, what we would have is a method that, by convention, ends with the word async, but it doesn't have to. And then generally, it will return a task of some kind. So this would either be a task or a task of T. And in that case, what a task is, it's just something that represents a concurrent operation. Now, something that's kind of important and subtle is that this may or may not happen on a separate thread. So we always think of, oh, well, asynchronous operations always happen on some other thread somewhere else. Well, there are situations where tasks complete immediately, so they don't actually do any processing. And in that case, they don't spin up another thread. They just stay on their current thread. Now, the stuff that I'm going to be showing tonight, we will be using a separate thread, and I'll be able to show that actually in the demonstration. And then the thing that's really, really powerful about task is the way that we can combine these, chain them together. So we can create one task that has several child tasks, and then when all of those complete, we do something else. We can chain them together, so when this one is done, do this. When this one is done, do this. When this one is done, do that. And we'll see some of the flexibility tonight. But I'm going to be showing a little tiny bit of task just to get our feet wet here. And so this is really kind of where we are as far as our kind of current patterns. So I'm going to go over to code now. Is that okay? Or do you want more slides? Code? OK, we'll go with code. So I have this application. Everyone's always amazed with my programming skills when I run my applications. Come on. You can do it. There you go. As we can see, we have a very complex UI that has 3 buttons on it in a list box. Are you guys impressed? I know it's still early. And then here is the asynchronous method that we're going to be consuming. Now, I'm not going to talk too much about how we create our own asynchronous methods tonight, just because that's a much, much bigger topic. So we're going to focus on consuming them. So in this case, I have this get method, and it returns a task. Okay, so like I mentioned, a task just represents a concurrent operation. And when a task has a generic type parameter, like we have here, we have a list of person, this is just a promise that at some point in the future, I'm going to get a list of person. So I'll have a populated collection of person objects at some point. And if we look at what a person is, it's a pretty simple class, actually. We'll just peek at that. And we can see it has an ID, a first name, a last name, a start date, and a rating. And then there's an override of the toString method. So this is just kind of the shape of our data. And then the stuff that really isn't all that important is what's happening in the rest of this application. Because as you can see, I have a lot of projects here. One of those happens to be a web API service that's actually returning us the data that we're actually going to use. Now, the thing that I want to point out in this method is this task.delay that I have here. And a task.delay is very similar to a thread.sleep. So you're probably familiar with thread.sleep. It's that little method that you use that you know you shouldn't be using, but sometimes you have to use it anyway. And what that will do is it will stop operation of the current thread for however many milliseconds we put into it. Now, task.delay behaves like thread.sleep in that this code will not run until after this 3-second delay has passed. But the difference is it doesn't actually block the thread. And that sounds subtle, but it becomes very important, especially when we're dealing with UI applications like we have here. Because even if we want to pause operation, we don't want to block a UI thread because that keeps people from interacting with our applications and things go really bad really quickly. Now, the rest of this is using an HTTP client, again, to call out to that web API service. We're not going to worry about anything below the task.delay. And then all this await is doing, we'll be looking at await, again, in a little more detail. This is just saying we're going to wait until this is done before continuing with this method. You with me so far? OK, so this is the method that we're going to be consuming. And I'm going to let Visual Studio help me out as much as possible because I am a lazy developer. So this is the code behind of my form. And I'm just going to be putting things in the code behind. Normally, I'd want a little better separation between my presentation and my UI. But we want to focus on task and await tonight. So I'm going to keep things simple. So I've got 2 button click event handlers, one for my fetch with task button and one for my fetch with await button. And then up here at the top, you can see I have an instance of that person repository class. That's that class we just looked at with the get method. So let's go ahead and use this. I'm going to fill in our fetch with task button to start with. Now, ultimately, what I need to do is call that get method on this repository object. So I'm not quite sure what to do at this point. So I'm just going to use some things that I know Visual Studio will help me out with. One of those is the var keyword. So I'm going to say var result equals repository.get. Now, the reason I'm doing this is because I know that Visual Studio will tell me what's behind this var. Because the var keyword, when people first walk up to it and they come from maybe a language that has variants in it, they think, oh, that means that's a variant, and we can put whatever we want in there. And that's not the case. In C#, var is still strongly typed, so it represents a specific type. But the difference is the compiler can figure out what that type is, so we don't have to type it in. So it's really good for lazy programmers like me. But what's really good is if I'm not quite sure what's coming back from this method, I can just hover my cursor over this, and it tells me that I'm getting a task of tResult. That's what this var is. And tResult is a list of person. So what this is telling me is this var actually represents a task of list of person, which really shouldn't be a surprise because that's what we saw in the method signature a couple minutes ago. So I'm going to be a little more explicit here to make this readable. So we'll change this to a task of list of person is what I'm getting back. And instead of calling this result, we'll go ahead and call this people task because it represents a task that will eventually give us back a collection of person objects. Does that make sense? OK. Now, we need to get the actual data out of this, right? Because the task is, again, just a promise that at some point in the future we're going to have this. And what's really tempting is to come into our task and say dot result. If I can type. And the reason this is so tempting is because if we hover over result, we see that this is actually the list of person. This is the data we ultimately want to get out of this method. Now, we do have a problem if I do people task.result right here. And the problem is that as soon as I call get, this task is going to kick off, so it'll start running. But when I get to this line of code, result won't be populated. And we know it's not going to be populated for at least 3 seconds because I have that delay operation in my asynchronous method. So what will happen is this will actually block the thread until this result gets populated. And that's not good because I'm on the UI thread, which means it's going to hang my application. Now, it's even worse than that because the UI thread in this case is waiting for the task to say it's done, and the task is waiting for the UI thread to say it's OK to do other stuff. So in this WPF application that I have here, it actually creates a deadlock if I do this, and that's even worse. So that means my application will never do anything after it's done hanging. So it's not just that 3-second delay. So I don't want to use result here. I want to look at result after the task is done. And so what I'm going to do instead of accessing the result right here is I'm going to add what's known as a continuation. And for this, we'll use the continue with method. And all a continuation is, it's just saying, hey, when this task is done, I want you to do something else. We're just continuing on. Now, here's where things get fun. I did mention that things are kind of flexible, right? I wish I could do this backwards, because I just want to do Control-Shift-Space to bring up the parameters here. Because notice this number right here.
A lot of overloads.
Yeah, it says there's 40 overloads of the continue with method. And continue with is just one method that we have in task. So like I said, task is very, very flexible. Now, fortunately for us, I'm just going to start with this first one. Now, I know you guys love nested generics, and we were looking at the list of the task of list of person before. But look at this parameter type. This is actually an action of task of list of person. Do you like that? That just makes you want to go home. Yeah, nested generic types. Now, another topic that I really love to talk about are delegates. An action is a built-in delegate type in the .NET world. And all action means is it represents a method that returns void, so it doesn't return anything, and then as a parameter, in this case it'll have one parameter that will take whatever this generic type is. So that means this will take a task of list of person as a parameter and then return void. So that's the kind of method that I need to put in here in order to satisfy this continue with method. So let me just create one of those. So we'll just come down here. I'll create a new private method. Again, it will return void. Ultimately, what I want to do is populate the list box. So we'll go ahead and call this populate list box. And then again, as a parameter, we want to take that task of list of person, whatever was inside the actions generic type parameter. So we'll say task of list of person. And we'll go ahead and just call this task. And then we just need to do whatever we want inside here. So what I'm going to do is I'm going to paste that method name up as a parameter in my continuation. So I say, when this task is done, I want you to run this method, populate listbox, and we'll do something with it here. So now inside this method, I can actually take our task and look at the result property. And again, this is a list of persons, so that's the data we're actually trying to get out of this. Now, I just told you it's really bad to access the task.result here, but it's okay here. Now, why is that? Well, it's pretty simple, really, because this method only runs after this first task is done. So that means result will be populated, assuming we don't have any exceptions, which we'll be looking at later. So when I say task.result here, I don't have to worry about, okay, I'm going to hang my thread while I wait for a result to populate. No, it's already populated because this continuation doesn't run until that result can be populated. Now, since this is a list of person, I want to make this nice and readable, so I'm just going to create a local variable called people that I'm going to assign to that so that now I can work with it. And then I want to put this into my list box, so I'm just going to use a for each. I love for each. So we'll say for each person in people, person listbox.items.add person. So I'm just going to loop through that collection of person objects that I have, stick each one into my list box. You with me so far? So let's go ahead and run this and see what happens. Go ahead and click on our button. We'll wait our 3 seconds, which is the longest 3 seconds in the world when you do demos. And we get an exception. Yeah, and this is actually, any UI programmer will recognize this exception.
Yep.
Does that look familiar? So the additional information says the calling thread cannot access this object because a different thread owns it. And what this means is I'm trying to access a UI object from not the UI thread. And .NET doesn't allow us to do that. So anyone who's done manual threading with a WinForms or WPF application will recognize this. And then to get around this, we would have to do something funky like marshalling the call back to the UI thread using a dispatcher.invoke and a whole bunch of fun stuff like that.
Is there a better way? I'm hoping you're about to say a better way.
I don't want to do any of that. So let me show you what we can do about this with our task. So basically what we want, let's do a stop debugging here, is I want to make sure this method runs on the UI thread, but I really don't care where that asynchronous get is running. That can run somewhere else. That's fine. So what I'm going to do is I'm going to add a hint to my continue with. There were a lot of parameters here, right? Let's look at number 8. Number 8 looks like a really good one. So for overload number 8, when we're looking at continue with, in addition to our action of task, we also have a task scheduler parameter. Now, what the task scheduler does is that's the thing that's responsible for figuring out, OK, what thread am I supposed to run this task on? When do I spin it up? What, do I have to wait for something else to happen before I spin this up? When it's completed, what do I do? So that's what the task scheduler is responsible for. Now, normally we don't have to worry about it too much, but in this case, I can actually use a static method that's on the task scheduler class. So I can say task scheduler dot from current synchronization context. That's a method, right? Yes. OK, and this is one of those things. Microsoft loves really long names for their things. So what from current synchronization context means is it means when you run this method, this populate list box, I want you to run it in the same context as where we're doing the assignment. Now, where are we doing the assignment? Well, we're doing the assignment inside a button click event handler, which is on the UI thread. So in this case, what we're saying is, please use the UI thread when you run this continuation method. You follow me? It's a little, takes a little while to kind of wrap your head around that. I wish it was the default, but it makes sense that it's not the default. And now, with that one change, by saying, hey, please run in this context, now I can see I click on my button, I wait my 3 seconds, and then my list box does actually get populated. That's much better than doing a dispatcher.invoke, right? So score 1 for task. Now I do want to prove that we're not locking up the UI thread. And so for that, I'm going to click the button again. And you'll notice my UI is still responsive during that delay time. So we don't end up with that not responding. Anyone who's done UI apps is really familiar with not responding. And you say, oh, do I have to kill the application or let it go? So this is one reason why I like to keep things off the UI thread. So we see that code actually, again, it's not overly complex, but we do kind of have to be familiar with some things. So again, with the event asynchronous pattern, calling a method, hooking up an event handler, that's kind of a no-brainer. Everybody can do this. But in this situation, well, we kind of have to be comfortable with generics, as we see, because we have nested generic types. We also have to be comfortable with delegates, because we have this action of task of list of persons, so we have to understand delegates. And it's actually pretty helpful to be familiar with lambda expressions as well. Now, I really love lambda expressions. And if you don't love lambda expressions, go out to my website. I have a YouTube series on learning to love lambdas. and because in this case, it's just a delegate. Watch what I can do with this. I'm not going to go into full details. I'm just going to kind of step you through this process a little bit at a time. Now, what I want to do is I want to get rid of this named delegate that we have here and create what's known as an anonymous delegate. And in that case, all we're going to do is basically inline this code. So I'm going to highlight the parameters and the method body. I'll say Control-C for copy. And then I'll come up here. I'll type in the delegate keyword, and then I'll paste. So I have the delegate keyword, the parameters, and the method body. What I've just done is inline that code. And I've just created what's known as an anonymous delegate. What's an anonymous delegate? It's a delegate without a name. So previous, the name was populate list box. Now we just have a delegate with no name that's just inline. Now it turns out a lambda expression, a lot of times the way we use them as anonymous delegates. So that means if I want to turn this into a lambda expression, all I have to do is delete the delegate keyword. And then in between the parameters and the method body, I add my lambda operator, which is that equals greater than sign. Now I have a lambda expression. That's all it is. Parameters, goes to operator, method body. That's kind of cool. Now, lambda expressions have a bunch of syntactic sugar. And we do that so we can make them very compact because, again, we do often put them in line as method parameters like we have here. One of those things is this really cool thing. It's known as parameter type inference. You should remember that, write it down, because when you say it at work, it makes you sound really smart. All that means is if the compiler can figure out the type of our parameter, we don't have to put it in explicitly. So that means that I can get rid of the type of this parameter. Now, how does Visual Studio know? Well, it told us, right? When I looked at the parameters, it says, you need an action of task of list a person. So what that tells it is, your parameter is a task of list a person. The compiler already knows what I'm allowed to put in here. And in fact, if I hover over this task, we'll see it is, in fact, a task of list a person. So the compiler can figure it out. I don't have to type it in. I love that as a lazy developer. Now, one other thing with lambda expressions is if you only have one parameter, you don't need parentheses around it. So this is a very common way to see people using continuations. Now, again, there's nothing wrong with using this separate named delegate that we started with. It works just fine. But often out in the wild, you'll see people that program like this, where they'll put a lambda expression inside the parameter of a continuation, inside starting a task, inside a factory method, those kinds of things.
So that's the general practice.
This is the common way of doing it. In fact, when I'm looking at delegates, if I ever see a parameter that has an action or a func, I treat that as a big flashing sign that says put your Lambda expression here. So action, again, is just represents a delegate that returns void, and then in this case it takes one parameter, but they can take up to 16 parameters. Yeah, be careful with that. Func is a lot like action, except it returns a value. So it'll return a value and then have between, actually technically 0 and 16 parameters. So again, if you want to get more comfortable with the syntax, I'd go take a look at that YouTube series that I have. It's actually kind of cool, if I do say so myself. So that means we can get rid of this separate method that we have here. And if I run the application, we'll see we get exactly the same behavior that we had before. So we haven't changed the functionality at all. We've just made it a little more compact and in line. You with me so far? Okay, so that's the basics of consuming an asynchronous method using task. And again, it's pretty common that we'll kick off whatever that asynchronous method is, grab onto our task, do a continuation. So we say, hey, when this is done, I want you to do this other thing. Yes?
And it doesn't change the fact that we need to use this hint for the from current?
No, so the question is, we still have to use this from current synchronization context. And the answer to that is yes, because this is still kind of the same as that separate method. We have to tell the continuation, where do I want to run this? Because this is technically another task. In fact, if I hover over this continue with method, whoop, this continue with, we'll see that it actually returns a task. So this continuation is another task. We're just not looking at the results of it in this case. So we do still have to pay attention. We do need this from current synchronization context.
I have one question.
Okay.
I hope it's not anything weird. But I always operated under the assumption that the reason why it was the nature of threads, that if you had something trying to communicate with a cross thread to the UI task, that was how you broke up your workloads. I'm wording this very poorly. If you're actually running this on the UI thread, but I guess my question is, how does it not lock up the UI?
My original task, this get, is running on not the UI thread.
That's not running.
The get.
Right.
Okay, and that's where we have that delay.
You're right. And then
right?
the delegate here, that's
right. So when it's done, this runs on the UI thread, which, since we're accessing this list box, that we really needed to do that.
I knew it was a stupid
Does that make sense?
question.
No, it's not. Totally not a stupid question, because this does get confusing. And again, there's a lot of flexibility, but also that usually means a lot of confusion too, as we're getting used to this. So yeah, definitely not a stupid question at all. So so we have this method is running once this one is complete. So this one is running on a separate thread, and we want this one to run on the UI thread. That makes sense?
Is it accurate to call that your callback method then, your continue with? Is that, or is that not right?
So that's actually a good question. We don't usually refer to these as callbacks. We refer to them as continuations.
Okay, continuation.
Because callbacks kind of have, that has more of an event handler connotation.
Okay.
So it's kind of a subtle difference. But are they locked out now? Did you lock yourself out? So for the basics of just kind of consuming this method, again, it's not overly complex, but there's kind of a bunch of little things that we have to understand. So I've always referred to task as kind of an intermediate level process. That's why I like the background worker component. I actually have an entire Pluralsight course on the background worker component, which has been around since .NET 2.0, because that is all property and event based, and so it's really, really easy to work with. And it's not as flexible as task, but if I just need to get something off the UI thread, it's brilliant for that. Okay, so we've seen the basics of using task. Let's talk a little bit about what await is. Because it turns out that await is just a wrapper around task. It's really cool syntax, but the compiler does a bunch of magic behind the scenes. Now, what await does is when we await a task, it pauses our current method until that task is done. So when we write our code, it's going to look like we're doing a blocking operation, but in reality, what it technically does is it creates a state machine in the IL. If you're one of those really nerdy people that likes to look at the intermediate language the compiler generates, do this and then you'll never look at it again. Just because it builds a state machine so that it knows, okay, I'm in the running state, I'm in the pause state, I'm in the done running, do this state. But again, it'll look like a blocking operation, but it's not. And that takes a little while to get your head around that. It makes things easier to program, but if you're used to other ways, like doing your own threads, it's a bit confusing. Now, the async keyword that we put on the method itself, people think that that magically turns the method asynchronous, and that's actually not the case. Async is just a hint to the compiler. And the reason for that is because we have this new await operator that we got in .NET 4.5. And we didn't want to break any existing code. Well, it turns out await was not a reserved word in C#. So it's possible if you were doing coding from .NET 4.0 and earlier, you might have had something in your code called await, maybe the name of a delegate, whatever, variables, whatnot. So what this does is if we flag our method as async, it says, okay, if you find the word await in this method, I want you to treat it in this special case. So that's really what it is. Doesn't actually do anything unless you have a wait somewhere in your method itself. Okay, that's enough slides. So let's consume this exact same method using await. So again, we can kind of compare these and see how they're the same and how they're different. Now again, I'm going to let Visual Studio help me out a bit here. And in this case, I'm just going to say repository.get. And then I'm going to hover over this and take a look at what my editor tooltip here gives me. Excuse me. Now, the first thing to note is this says this method is awaitable. Okay, so that implies I can use the await keyword with it. And the primary reason for that is it does return a task. Again, that's the task of list a person that we saw earlier. Even better, Visual Studio says, hey, here's a way that you can use this. So we can say list of person, okay, that's ultimately what we want to get out of it, right? That's our result. List of person X equals await get. So it's saying, here's the syntax you have to use if you want to use the await operator with this. I love that. Please tell me how to do this. So we'll say list of person, we'll call it people, equals await repository.get. Okay, so Visual Studio is obviously not happy with me here, even though I did exactly what it told me to do. Well, if we hover over this, what this will tell us is the await operator can only be used in an async method. So you need to mark this as async. Now, if you're a really lazy developer, you'll notice I have a little light bulb here. I can use the keyboard shortcut Control Dot to bring up the pop-ups for that. And this one says, hey, do you want me to add async to this method? Bloop, OK. So it just added the async modifier to the method. Now, normally I would just go in and type in those 5 characters because it's not that much. But I do love keyboard shortcuts, but usually when they're doing something a little more than that. Now you'll notice my red squigglies have gone away. And OK, so I have list of person people equals await.get. Well, what do I do now? Well, I have a list of person. What did I do with that before? Well, I just for each through it and put it in my list box, right? So we'll say for each person and people, person list box.items.add person.
That's all she wrote?
That's all I have to write. Huh, really? Well, let's go ahead and click on that and see what happens. It works. And you know what? It doesn't block my UI thread. So it's still a non-blocking operation. Now I heard someone say, well, what about the UI thread? And that's actually a very good comment, because we had to put this from current synchronization context when we were doing task, right? Well, it turns out that await by default will grab the current context. So by default, it'll say, oh, I'm in the UI. I'm going to grab the synchronization context and go ahead and use that. So then the rest of this code, after this is done, will run on the UI thread. That's pretty cool. Now, there might be a time where you don't want to do that. And generally, this might be when you're doing library code, for example. So if I'm writing a library that has asynchronous method calls in it, then in that situation, I'm not responsible for figuring out that I'm on the UI thread or not, which is generally why we care about it. There's other situations you might want to hang on to the current thread. So in those situations, we might say, well, I don't want to grab the context because that's actually overhead that I don't need. And there's actually an extension method that we can use to say, don't use the current synchronization context. And you might have heard of this. So on the get method, again, this returns a task. I can say, configure await, and then this takes a true-false value. And so if I say configure await false, it won't hang on to that current synchronization context, and it will use whatever thread it wants to use. Again, it's up to the task scheduler to figure that out, thread, pull thread, new thread, whatever. I don't care, the scheduler.
Now that's going to crash your...
Yes, so if I were to run this, then we would have that same error that we saw before with task by default. So we will get the exception that says, hey, you're not on the UI thread, you're trying to access a UI element. Does that make sense? So await defaults the other way. So let's go ahead and stop debugging and take out that configure await false. Now there is also a configure await true, which that's the default, so I don't know why you would ever use that, but I guess you can do that. So this is all we have to do with await. And it does look kind of magical, because this just looks like a synchronous operation that we would do. And normally, if I was writing something without this await keyword here, and I hit something that took a long time to do, it would hang my UI thread. I'd have to wait for that stuff to return, and then my UI thread would start responding again. So again, this looks like a blocking operation, but it's not. Yes?
I thought you said that if we look at the EL language generated, it has a state machine. I thought that what really does the compiler is this, that grabs everything which creates this delegate for us, like what we...
Yeah, it kind of does what we do up here, but this also kind of does a state machine with the task scheduler. So yeah, this is actually breaking it up and doing the continuation that we did here, because again, this is just task. So we're still dealing with a task. If we look in the IO, we would see tasks sprinkled everywhere. But in this code that we write in our own, user space, we don't see the task at all. It's all hidden from us. Obviously, if I hover over get, this will say this does return a task, but because I'm awaiting it, all I see is the ultimate result, which is the list of person. So again, like I said, if this is what you walk up to the first time, and you've never done asynchronous programming before, you've never had to do threading yourself, you've never had to use one of these other patterns, it's kind of like, well, this just looks like any other code that I would write. And it is a little bit magical. But again, it is very helpful to understand what's going on behind it, because there are situations where we can't use this. For example, if I write a console application, and I have my main entry point, I can't use await in there. Do you know why? Because you're not allowed to mark that entry point as an asynchronous method. And async tends to propagate. Totally not going to talk about that tonight. We're just going to kind of focus on this stuff right here. OK, so we have two different ways to consume this method, and we're populating our list box. And again, we can click our fetch with task button. Our UI stays responsive during the meantime. Fetch with await, or if I can click right, our UI stays responsive in the meantime. But we do have a little bit of a problem. Watch what happens when I click this await button multiple times. 1, 2, 3, 4. 1, 2, 3, 4. I actually got 4 result sets come back. And you might say, oh, well, Jeremy, you should clear your list box. Well, I am clearing the list box. I'm clearing it up here right at the top of the method. But the problem is that's when I'm clicking the button. So when I click the button 4 times, it goes clear, 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 clear. And then the data starts coming back. Data set 1, data set 2, data set 3, data set 4. So that's why I'm getting that behavior. Now, you might say, oh, well, what do we do about that? I'm going to do the simplest thing possible. I'm going to disable the button. We don't always have to overthink how we deal with these situations. But we do need to keep in mind that as soon as, especially when we're dealing with UIs, as soon as we start putting asynchronous methods in our UIs, our users are going to find interesting ways to break our applications. This happens to be one of them.
Would moving the cleared list box after the repository, the .get, also accomplish the same thing? Or no?
Let's try it. It will and it won't at the same time. So oh wait, actually no.
Yeah.
You're right. Yeah, not there, but there.
And if you would leave it also before, because then it wouldn't.
Yeah, that's what I was going to show. So this seems to work okay, like that, the first time I do it. But watch what happens when I click it now. It didn't clear it when I click the button because we're not clearing it until after the get is done.
Okay.
Do you see what I'm saying?
So it's a little UI nuance.
Yeah, so yeah, and I could put it in both places, like Chaba suggested. But then we're at the point where it's like,
now you're starting to look like my code.
yeah. Yeah, and then we have to ask ourselves another question. Do we really want to go through this process of fetching the data multiple times? And the answer is probably not. If someone clicks the button 4 times, I don't want to call the service 4 times. That doesn't make sense. So again, in this case, it would make sense for us to really kind of deal with the UI. And so what I'm going to do is just disable the button. So at the top of this, we'll say fetch with await button dot is enabled equals false. And then down at the bottom of the method, we'll set this back to true. And so now when we run this, when I click the button, you can see the button's disabled. I can't click it again until after the data comes back. Sometimes the answers are simple. Because again, once we start putting that, well, I should clear it here, and clear it here, and maybe clear it here. So sometimes the simplest answers are like, well, let's just keep them from clicking the button. I don't want to keep calling the service every time, in between, because I'm only showing one data set ultimately. Now, we do have a little bit of worry to think about, because what happens if I get an exception somewhere in this block of code? Well, if I get an exception, then my button is not going to re-enable, right? So I want to wrap this in a way so that if I do get an exception here, I will still re-enable that button at the end. How would I normally do that? Any suggestions? Try. Try is a good start. Try finally is even better. I'm not going to worry about catching the exception at this point. I just want to make sure this code runs even if there's an exception. Now, like I mentioned, I love keyboard shortcuts. This is a spot where I would actually use them. Notice I have this block of code highlighted. I use the keyboard shortcut Control-K, Control-S, which is the magic keyboard shortcut for surround with. And I get a set of snippets that I can use that have bodies in them. I'll type in try F, which is the code snippet for a try finally block. It's going to take that block of code I had highlighted, wrap it in a try block, give me a finally block, put my cursor in the finally block so I can start typing. I love that kind of stuff because I am a lazy programmer. And so what that means is all I need to do is just move this block of code where I'm re-enabling the button into the finally block. And it still runs the same way. I won't bother running it again. And then up here, with our fetch with task button, we'll do something similar. So again, up here at the top, we'll go ahead and say fetch with task button dot is enabled equals false. And then my first inclination is to come down to the bottom of my method and set it back to true.
No.
You guys don't like that?
No.
No? Okay, because it didn't actually do anything, did it? It actually did. At the top, it disabled my button. And then it kicked off the task. It assigned the continuation, and then this keeps running. So this runs pretty much immediately, and that's why we don't see it enable or disable. And so really where I want this re-enabled is inside the continuation to say, okay, once the data has come back, go ahead and re-enable the button. And then if we do this, we'll see we get that behavior that we would expect where our button actually is disabled until the data comes back and it re-enables. Now we could come in here and say, okay, well if there's an exception, try catch or try finally. I won't do that right now because we're going to be looking at exception handling like right now. Because we have to think about what happens if something goes wrong in that asynchronous method that we're calling, right? Well, I'm going to start out by looking at the await operator because it's a little bit easier to deal with. So I'm going to flip over to my asynchronous method, and after our task.delay, I'm just going to throw a new not implemented exception, and I'll say get method is not implemented. Okay, so our asynchronous method is going to throw an exception now. Let me just go ahead and rebuild, make sure that I got the syntax on that okay. And before I make any changes, let me just go ahead and run my application and click on my await button to see what happens. And what we'll see is we have an unhandled exception. And notice where it's pointing. It's actually pointing at the get method and saying, hey, you know what? This method threw an exception. And if we look at the additional information here, we see it says get method is not implemented. So it actually got the message from the exception that we threw. OK. So how do I deal with an exception in this block of code? Any ideas? Here's a hint. I already have a try block. Add a catch. That's it. And that's the magic of using the await operator, is it looks like synchronous code. We treat it just like any other code we would write. So yes, I add a catch block. And in this case, I'm just going to catch all exceptions. Normally, I don't recommend that, but we'll see this will actually come into play a little bit later on. We could catch the explicit not implemented exception here if we'd like. And in this case, I'm just going to do a messagebox.show. We'll say ex.message, and then we'll give this a header of error, because we're going to have some other message box popping up a little bit later. So now if we run this application, click on the fetch with await, we'll wait our 3 seconds, we'll get our exception, we hit our catch block, and it says get method not implemented, and it's kind of hard to read, but the title there does say error. And then as soon as I click OK, we'll see our button re-enables. That's really easy. And again, that's one of the things I really like about using the await operator, is because we do treat it just like any other code. So let's see what happens when we click on the task button. OK, now this is a little bit different. Now notice where we are. We're inside of our continuation. And our exception is pointing at this result property. So what's happening is we're trying to access the result property, and it's saying, you can't do that because an exception was thrown. Now normally, when we're dealing with multiple threads, exceptions will stay on whatever thread they're generated on. They don't normally cross threads. And the same is true here. But the difference is that inside of our continuation, when we get an exception on a task, it's put into what's known as the faulted state. And when a task is in the faulted state, it means, hey, there was an exception thrown in the task. But it also means that the result property is not valid. And it's not even that result is null. It's just accessing the result property is not allowed. And the message that we get is not quite as helpful as the one we had with await, because if we look at this, the additional information says one or more errors occurred. That's interesting. It's actually an aggregate exception. And I'm going to talk about that in just a few minutes. We won't worry about that for the time being.
View details, do we have an exception in it?
I will get to that. For now, let's just figure out how to get this code to work. I could do this the interesting way or the easy way, or both. You guys totally want to see the interesting way. OK, so I'm going to actually end up showing both. And this will give you an idea of the power of task continuations. So I don't want to access this result property unless my task completes successfully. So what I'm going to do is I'm going to pick another overload from the list. I think I want number 17. Oh, yeah, that's totally the one that I want. Now, you'll notice here this has 4 parameters. 2 that we already have. So it has the action of task of list a person. That's good. That's our Lambda expression. It also has our task scheduler. We need that because, again, we need to tell it go back to the UI thread. Now, the additional parameter that I really want is this one, which is task continuation options. Now, unfortunately, there's no overload that just has those 3 parameters. So this overload is the closest one that I can get, which also has a cancellation token. Well, I don't need a cancellation token because I'm not dealing with that right now. But I obviously need to stick something in this parameter. Now, it's really, really tempting to say, you know what, I'm going to put a null in for the cancellation token. But that's really a bad idea. And in fact, it turns out that cancellation token has a static property we can use, which is kind of cool. So we'll say cancellation token dot none. And what that says is, well, I need a cancellation token to pass into this method, but I don't need a real one. I just need a placeholder. So we can pass in cancellation token dot none, and that's better than passing in a null or just a cancellation token we don't care about, because this doesn't take any processing. We don't have to new anything up. And then, like I said, the one that I really want is the task continuation options, which happens to be an enum. And the ones that I want to look at here are these ones that say not and only. So what we can do is we can specify when do I want this particular continuation to run. I can say only on canceled, meaning I only want to run this cancellation if it was canceled. Only on faulted, only run it if there's an exception. Only on ran to completion, if it's successful, run this.
Crazy flexible.
Yes,
Yeah.
And then there's also the not. So I can say not on canceled, in which case it would run if it's either completed successfully or faulted. I could say not on faulted, which means completed successfully or canceled. Or I could say not on ran to completion, which means if you are canceled or faulted, do this. So between these 6 options, we can basically get any combination of these 3 end states that we end up with.
What's long running do?
That's something I'm totally not going to talk about.
Okay.
Yeah, there's ways to say this is a long-running task, and it gives a hint to the task scheduler of, like, what kind of thread do I want to run this on? We're looking at maybe 2.5% of what task is capable of tonight. So in this case, I'm going to say only on ran to completion. So what I'm saying here is that I only want to run this block of code if that task finishes successfully. So if there's an error, I don't run this, which means I won't try to access that result property, and I won't have any problems. So let's see what happens. So when we run this, we'll click on our button, and we'll wait our 3 seconds. Then we'll wait our 3 seconds. We'll basically wait forever. Because our task threw an exception, and so our continuation did not run, which is good. That's what we were looking for. But this line that re-enables our button is inside the continuation that didn't run. So what I can do is create another continuation. This is where things get really fun. So I can say people task dot continue with, and then we'll say task goes to, we'll fill in some curly braces in a second, and then we'll say this will be, actually I want this to always run, so I don't need a continuation option, so I'll just say task scheduler dot from current synchronization context, because I do need the UI thread, because I'm going to be touching a button. So I'll be moving this down here. So on this people task, this thing that's created up here, now I have two separate continuations. One that will run only if it's successful, and one that will run always to re-enable the button. With me so far? Okay, this is really flexible. Okay, so let's go ahead and click the button, and then we'll wait our 3 seconds, and then we'll see that our button re-enables. And that's all that happens. Now remember how I talked about exceptions stay on their own thread unless we go looking for them? That's exactly what happened here. That exception is still getting thrown, but since we're not doing anything that kind of surfaces it on the UI thread, we don't see it here. Okay, well, we want to do something with that exception, right? What I'm going to do is I'm going to create another continuation. Ooh, these continuations are really flexible, aren't they? So we'll say people task dot continue with, okay, and again we'll say task goes to, and we'll put our curly braces in. We'll fill that in just a second. And this one I do want task continuation options on. So we'll say, we'll start with cancellation token dot none, and then we'll say task continuation options dot only on faulted. Okay, so we'll say this will only run if there's a problem in the background. And since I'm going to be doing a messagebox.show, I need to be on my UI thread, so we'll say task scheduler dot from current synchronization context.
So why don't the others show the exception?
Because we haven't asked for it.
The blank one, though. That middle one. We didn't.
This one? The only reason we saw the exception is because I tried to access this result property that I'm not allowed to access. Since I'm not accessing the result property,
You're just enabling that.
yeah, it doesn't care. So the exception stays on its own thread unless we go looking for it. And again, that can be dangerous. If we don't go looking for it, we might not know that something went wrong. But again, if normally we're looking for a result to come back from that asynchronous process. Sometimes we just want to know that it's done.
Is that true behavior of exceptions for any thread?
It is true for threading. Yeah. If I create my own thread and throw an exception on it, I'm not going to see it.
Okay.
Now, when we run this in the debugger, then a lot of times our environment will stop on the exception and say, hey, here's something that went wrong. But if we actually run the application at runtime, we don't see it.
Okay, that makes sense.
So yeah, that's another subtle thing. Yeah, did you have a question?
Chain the continue with to the end of the other continue with?
So the question is, can we chain these together? And the answer is absolutely yes. Because, as I kind of pointed out, this continue with returns a task. So I could actually get the result of this first one and say dot continue with this other one, get the result of that and say continue with this other one. Now, you kind of have to be careful with that. In this case, I'm writing 3 continuations on the same task, which means that not technically, but from an observational perspective, these guys all run at the same time once that first task is done. And it will become clear as soon as I fill in this guy right here. So we'll say messagebox.show. So again, this is in our block of code where we're saying on faulted, do something. Okay, now I want to get to the exception. This time I'm looking for it. Now I don't want to call the result property and do a try catch because that sounds like way more complicated than I really need it to be. What I can do though is that look at the task itself because the task has an exception property on it. Okay, so I'll just say task.exception.message and then we'll say error like we did with our await block. And let's go ahead and run this and just kind of see how it behaves right now. So we'll go ahead and click on our button. We'll wait our 3 seconds. And then we got our pop-up that says one or more errors occurred. But notice that our button has re-enabled as well. Both of those continuations ran at the same time. I mean, technically not at the same time because nothing happens at the same time on computers. But because we have continuations on the same task, they run at the same time. Now, if we were to chain it together and say, I want you to run the re-enable task after this one is done, again, we could grab the result to continue with, grab the result to continue with. For this particular example, it gets kind of hairy because we want this one to run on both cases, and it might not do what we expect when we have those task continuation options in there.
Depending on the order, if you dot chain them together, you're not getting certain ones down the line.
Yeah,
or you're not going to achieve the sequence.
Because this task isn't going to run because we've said, I only want you to run this on success state.
Yeah.
So again, extremely flexible.
That's good.
With great power comes great responsibility. But I still have this problem because it says one or more errors occurred. So let's take a closer look at the actual exception that we're getting back from this. Now, if we look at the exception on task, we're going to see something that's kind of unique to the task world. And that is, we don't have a normal exception, we have something that's called an aggregate exception. And the reason we have this is because task is so flexible. So like I said, let's say we have a parent task that kicks off 5 child tasks. 2 of those child tasks complete successfully, 3 of them throw exceptions. Which exception should we show? Should we show the first one? Well, first is dangerous when we're talking about concurrent operations because, that's undefined. So instead, what we get is we get all of the exceptions. And we have an aggregate exception because we say, okay, well, the three tasks at this level threw exceptions. So here's those exceptions, all kind of in a tree structure. And then it gets even better because we can take those tasks and chain them to other tasks and chain them to other tasks. So basically, the exceptions that we get in this collection are also aggregate exceptions. So we end up with this big, nasty tree structure. Now, we can go through and navigate that tree structure if we really care about it. But in a situation like this, I probably just want to log the exceptions somewhere. I want to tell my user something went wrong, but I don't want to show my user everything that went wrong. So what I probably want to do is just figure out a way to kind of iterate through these so I can log them, so that I can go and put better exception handling in my code somewhere else. Does that make sense? So the easiest way to do this is using a magical method on flatten, or on aggregate exception. So if I look at task.exception, whoa, there we go, awesome. Task.exception, again, this is an aggregate exception. Oh, cool, I killed it. Bloop. Think about it, there we go. This is an aggregate exception. Now this does have a .inner exceptions on it, but that inner exceptions is also a collection of aggregate exceptions. But I can say task.exception.flatten. And what that will do is it will take that tree structure and turn it into a single level. So if I say .flatten.inner exceptions, now I have a single level list of exceptions that happen. So this is a really easy way to take that tree structure and turn it into something that we can actually iterate through really easily.
That's a good hint.
Yeah, it's awesome.
I can see you coding for
Again,
a long time without being aware of
you don't want to know how long it took me to figure out how to use that. So in this case, I'm going to do something that I wouldn't recommend doing. And that is, I'm going to for each over this collection of exceptions. Okay, so we'll for each var ex in inner exceptions. And then we will just show each message in a pop-up box. Now again, I wouldn't recommend this for a real application because if I did have multiple exceptions, I would get multiple pop-ups. I'd get a pop-up, you click OK, get another pop-up, you click OK, get another pop-up. But for our purposes, it will show us kind of how to get to that exception that we're really looking for in this case. So now let's go ahead and run our application. We'll click on our button, we'll wait our 3 seconds. We get our pop-up message that now says, get method is not implemented. So it's showing the message of the actual exception that was thrown. Now, we can't just assume that we have a single exception in this collection. Because yes, I am making a single call to this get method, but I have no idea what it's doing. Maybe it's spawning off multiple tasks. I don't know. So when I'm dealing with these asynchronous methods with task, I have to be prepared for an aggregate exception coming back. And again, maybe that means I need to log this collection somewhere or do something with that, but I can't just assume that there will only be one exception that comes back. Yeah, it's kind of insidious. Okay. So now we have these three continuations, and my code is kind of building, right? And this is cool. Again, this is showing me the flexibility that we have in task. But for this particular scenario, this is kind of overbuilt. Because I've got this block of code, or this block of code, or this block of code. So I have 3 lines up here, I have 2 lines here, and I have 1 line there. I kind of want them in a single continuation so I can deal with them easier. And I can actually do that because there's some properties that we can look at on the task itself that we can just put some conditionals on. So let me show you what I mean by that. Let's come back to our original continuation. And I'm going to get rid of the task continuation options. Okay, so I'm kind of back where we started with this continuation will always run. So let me go ahead, and I'm just going to copy my other code back into this block. We'll get rid of these separate continuations. So now I just have one continuation that always runs. But I am going to have problems because if I check my exception property when it's not faulted, I'm going to get a null reference error here. If I check the result property, if it is faulted, then I'm going to get an exception here. So let's add some conditionals here. Turns out the task has some really useful properties. So I can say task.is. And notice I have an is canceled, is completed, and is faulted. OK, that makes things easier because I can say if it's faulted, go ahead and run this block of code right here. Let me scroll out a little bit. So if it's faulted, go ahead and run this exception handling code. And I could come in here and say else, run this block of code. But else doesn't really work for us very well because I also want to think about cancellation, which we'll be looking at in just a minute. So I might have if task.is canceled, then we want to handle cancellation. And then, you know what? That other property looked pretty promising, right? Is completed, right? That sounds good. Let's go ahead and wrap that in an is completed. And then re-enabling my button is way down at the bottom outside all of these conditionals. OK, so I have one continuation that's going to run now because I really don't need the flexibility of all those separate ones. If it's faulted, this code will run. If it's canceled, well, nothing will run. If it's completed, then this code will run. And then regardless, I'll re-enable my button. That looks pretty promising, doesn't it? So let's go ahead and run this. Bloop. And we'll click our button. We'll wait our 3 seconds. We get our pop-up message that says get method is not implemented. We say OK. And I get an exception on the task.result. Why am I in this block of code?
It didn't say is successful, it just is complete.
That is correct. Is completed does not mean what it should mean. Is completed really should mean completed successfully. But if we look at the documentation, what we find is that is completed will return true when the task is in one of 3 final states: ran to completion, faulted, or canceled.
Well, that's useful then.
So is completed simply means no longer running. So that's not going to take care of the code that we have right here. Now, fortunately, there is another property, which is the status property. And if we look at status, what we'll see is this is actually an enum. There we go. And this actually has things that are useful. Canceled, created, faulted, ran to completion, which actually does mean completed successfully, running, waiting for activation, waiting for children, blah, blah, blah. And since this is an enum, that means it can only be in one of these states. So these are mutually exclusive. Ran to completion does mean completed successfully. So that means we can actually use that here. So I can say status equals task status dot ran to completion. And if I do that, now I'll get the behavior that I expect. So we'll click on the button, we'll get our pop-up message, and then we click OK, and our button re-enables. Okay, so, but, okay, I just screwed up the code now, right? Because I have, this one says status, and these ones say is. I want these to match, right? So we'll say status equals task status dot canceled, and then we'll come up here and we'll say status equals task status dot faulted. Okay.
Could you write this into an if else, like if task not, so there would be an if faulted. And
So the question is, could we write this in an if else, like if else. If else, if else.
Yeah, no, we can't. Sorry, I just realized that we can't.
Well, we can actually do something better, because we said status is mutually exclusive, right? And it's an enum. And since these are mutually exclusive, normally what would I use for that? A switch. Have you guys ever used the switch code snippet with an enum? Let me show you. Again, lazy developer. Love this stuff. So I'm going to type in switch. I'm going to hit tab twice, which will invoke my code snippet. And notice it says switch on. That's highlighted. So I'm going to say task.status. Are you ready? Boop. When you use the switch code snippet on an enum, it fills in all of the cases for you.
I did not know that. That's pretty cool.
That is so awesome. I love that. That's one of my favorite things.
This is a guy who's blocked to follow people.
Now, since we're in a continuation, meaning my task is done, right? It's no longer running, I can get rid of a lot of these because I don't need created, I don't need waiting for activation, waiting for run, because this stuff is already done. That's already gone by. So I can actually delete all of these except for the ones that I care about, which happen to be ran to completion, canceled, and faulted. And then all I have to do is just move my code into these blocks, which are now in reverse order for those of you playing along at home. Okay, and we'll get our success block up here. And then we can get rid of all these nasty if statements. And then again, my re-enabling the button is outside of the switch statement, so this will always run. That code looks much cleaner, doesn't it? That makes me happier. Because to me, mutually exclusive means I want a switch statement. Okay, and we click it, and then we'll get the behavior that we expect. Again, there's our method is not implemented. Our button re-enables. That's good stuff. Okay, so let's go ahead and pull out our exception. Let's just comment that out. We'll run it again. Make sure that our happy path still works. Right now, with our wait button, that shouldn't be a surprise because we just have that try catch finally block, so that still runs the same. And then our fetch with task, same thing. Now we're just going to hit a different section of our switch statement. We're going to populate our list box, and our button re-enables. Okay, so that's good. Our happy path still works. Now, there's one other thing that I want to look at tonight, and that is cancellation. And the reason I want to look at it is because I've got this cool cancel button that doesn't do anything. The other reason I want to look at it is because cancellation has some hurdles that took me a really long time to figure out. And I want to make it easy for you guys, so you don't have to take a really long time to figure this out. Now, I am going to have to modify our asynchronous method a little bit because I need it to support cancellation. And so for that, what I'm going to do is I'm going to add a parameter, which is a cancellation token. Now, cancellation token is just an object that can kind of be in one of two states. It can be in cancellation requested state or not cancellation requested state. So we can think of this as a flag. It's just a little thing that says hey, please cancel when you get a chance. But we actually have to look at that flag and do something with it. So I want a cancellation token as a parameter. And we'll go ahead and call this cancel token. Now, I don't want to break any of my existing code. So I want to make this an optional parameter. So I'm going to give it a default value. And for that, I'm just going to new up an empty cancellation token. OK, red squiggly should go away.
I thought that you can use that now.
Well, you actually can't here. Default, when you put in a default value for a parameter, there's certain things you can do, certain things you can't do. So you can't actually put in a cancellation token.none. So instead, what we have to do is just new up a new cancellation token. And if we don't pass any parameters in here, then this will be a cancellation token in the not cancellation requested state. So that means whenever we check this, it'll say, nobody wants cancellation, keep doing whatever you're doing. And again, that's our default behavior if nobody passes in a cancellation token. Now inside, I'm going to check our cancellation token again after our delay. And I need to think about what I want to do. OK, so cancel token has like an is cancellation requested property. OK, so that's a true-false flag that I can check. But if that's true, I have to get my task into a canceled state somehow. Right, which means I have to set the status to canceled. I need to set the is canceled property to true, and some other stuff that I don't know exactly what I need to do. So I don't want to deal with this manually. Instead, the cancellation token has a method that we're supposed to use in this case. A lot of people don't want to use this because it's called throw if cancellation requested. Now the reason people don't want to use this method is because it has the word throw in it. And that kind of implies that it's going to throw an exception. And we don't like to throw exceptions unless we really have to, because exceptions are programmatically expensive. Because every time we throw an exception, it has to unwind the call stack and put everything together, create this object, and blah, blah, blah. So we want to avoid throwing exceptions where we can. In this case, this is exactly what we want to do, because we want the task infrastructure to deal with this for us. So what this is going to do is going to throw an operation canceled exception, which the task infrastructure deals with in a special way. What does it do? Well, it doesn't set the faulted property like it would on any other exception. Instead, it sets the canceled property. And it sets the status into canceled. It sets that is canceled to true, sets that is completed to true. And it handles all of that for us. So this is really what we want to do. Now, when we talk about where we can check cancellation in an asynchronous method, woo, that was almost a disaster. That's, and dealing with cancellation is actually kind of a disaster too, because we have to think about, is our operation actually cancelable? If I have a loop, for example, I'm iterating through files and processing them, it's really easy to check the cancellation token each time through the loop. And if I hit it, I'm not going to process the rest of them. But what if I'm making a service call? Well, if I'm making a service call, I'm waiting for data to come back. I can't really do anything to stop it in the middle. But what I can do is once that data comes back, I can check and see, oh, well, someone requested cancellation, so I'm not going to continue sending this data on. Maybe I'm going to do something else. So again, that's kind of a bigger topic when we're talking about creating our own cancellation, or I'm sorry, creating our own asynchronous methods that support cancellation. In our case, I'm checking it after the task.delay, so it gives us 3 seconds to click on the cancel button. So that's why I'm checking it here. And if I checked it at the top, it would check it immediately. And we could actually check it multiple times. I could put this same method here, 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 and here if I wanted to. We'll just put it here for now. OK, and then again, because I made it so that we have that default parameter, nothing's going to happen right now. The stuff is just going to run to completion because we're not passing in a cancellation token. So in this case, I'm going to start with the task. It's actually easier to start with task in this case, which sounds kind of weird because it's been easier to start with await for everything else. So what I'm going to do is on the get method, I'm not going to hook it up to the button right now. Instead, what I'm going to do is I'm going to pass in a hard-coded token that says This is in a cancellation requested state. So I'm going to say new cancellation token. I'm going to pass in true, which means that I want this to be in the canceled state when I create it. Does that make sense? If I say false or leave it empty, the default value, it'll say this should be in a not cancellation requested state. Now, obviously, this isn't real useful in the real world, but we'll be able to check our code paths. So when I run this, and now I click on the Fetch with Task button, we'll wait our 3 seconds, and what we'll see is our button re-enables and nothing else happens. And that is exactly what we expect to happen, because inside of our switch statement, I just have a comment that says, hey, do something with cancellation. Now, I'm just going to do a messagebox.show and say cancellation requested, and then we'll give this a header of canceled. Yeah, don't get me on the 1L, 2L things for canceled, because the background worker component uses a 2L canceled, and everything else uses a 1L canceled. Okay, so now if we run this, I click the Fetch with Task button. Now we'll see we get a pop-up box that says cancellation requested, and I say OK, and the button re-enables. Okay, so that's pretty easy to deal with. Now again, we'll hook this up to the button in just a minute. But before we do that, let's go ahead and look at our await button. And again, I'll start out by just putting a hard-coded cancellation token as a parameter to our get method. So we'll say new cancellation token true. And let's just see how our button behaves. So we'll click on the Fetch Data with Await button. And I got a message box. And it's my error message box. And it says the operation was canceled. That's kind of interesting. Well, the reason for that is, like I said, when we say throw of cancellation requested, it will throw an operation canceled exception. And the way that await works is it will bring that up to the UI thread so that we can see it. So it's actually getting caught by our exception handler that's grabbing every single exception. That's kind of interesting. Now, why would we program against an exception, right? Again, people kind of balk at, hey, there's that throw. I don't want to throw unless I really need to throw. But the question is, how else would we know that this task was put into a canceled state? Because we don't see the task anywhere in here, right? So we can't check the status to see if it's canceled. We can't check the isCanceled property to see if it's true. How else are we going to know? So the designers of this said, we're going to throw an exception. It'll be an operation canceled exception, which means you can catch it separately and do something custom with it. So all we need to do to deal with cancellation is add another catch block. So we can catch an operation canceled exception and do whatever we want to do. And again, I'm just going to do a messagebox.show. Actually, we'll say ex.message, and then we'll say canceled again as the header. And again, we could just do whatever we need to do inside that block of code. So now if we click on our Fetch with Await button, we'll see we get a pop-up that says operation was canceled, but it's really hard to see. Our header actually does say canceled, so we're getting that second message box. So now we can have two separate catch blocks. We catch an operation canceled exception, and we can deal with cancellation however we want to do that. Could be that we put something in the status bar, clear out the list box, light up a button, whatever we want to do. And then we can grab other exceptions that might happen from that completely separately. Does that make sense? Okay, so now that we have that, let's see what we can do to hook it up to the button. Because I want this canceled button to actually do something. So here's what I would do without knowing any better, which is the way I program most of the time. I would say, okay, let's come up to the top of our class. Let me create a class level cancellation token. We'll call it cancel token. And then I have my event handler for my cancel button. And I would take that token and I would say .cancel on it. Except it doesn't have a .cancel. Okay, .stop, halt dot, okay. This is all that we have on a cancellation token. These are all of our properties and methods. And you might say, oh, is cancellation requested? That looks promising, let's set that. Nope, that is a read-only property. It turns out that if we create a cancellation token by saying new cancellation token, it is read-only as soon as we create it. So when I create it, I can pass in a true or false to say whether is cancellation requested is true or false, but I can't modify it after I have it. How useful is that? It's not useful at all, is it? And this is why you want to read documentation, because you don't want to know how long I spent on this problem trying to figure out how do I modify a cancellation token? Well, it turns out that we don't actually want to create a cancellation token. Instead, we want to use this magical object, which is called a cancellation token source. What's a cancellation token source? It's an object that's responsible for managing a cancellation token. Okay, so if I have that token source, and I say .token, then what I can see is this is an actual cancellation token. So this is what I can use to pass into my methods that want a cancellation token. But more importantly, this has a .cancel method, which will actually set that cancellation token into the cancellation requested state. Now, interestingly enough, there's also this cancel after method, which takes a time span as a parameter. So in that case, you can cancel it after 1 second, 5 seconds, 5 minutes, random interval of time.
Is that the proper way to give your task a timeout then?
So I've had people ask me about timeouts on this, and I still haven't come up with a good answer to that because I don't have a good way to use cancel after. I haven't seen it used as a timeout, but someone suggested that when I did this previously. And I was thinking about it, and I'm like, yes and no, but there's a difference to me between this was canceled and this timed out. You know what I mean?
Yeah.
So it doesn't feel right to me. So I still need to do some more pondering about that. But that's a good train of thought to think about. We'll just use cancel in this case. Okay, so in my button click event handler, we'll just call cancel. And again, that will put our token into a cancellation requested state. And let's start out with our await button. So that means instead of using this hard-coded cancellation token, we'll say token source.token. So that's what we're going to pass into our get method. Now there's one other thing that I need to do is I need to create an instance of my cancellation token source. I'm actually going to do it at the top of this method. So we'll say token source equals new cancellation token source. The reason why I'm doing it here is that there's no way to uncancel a token. So I have my token source, and I can call the cancel method, but there's no way for me to say uncancel. So each time I click my button, I actually want a fresh cancellation token that's in the not cancellation requested state so that I can set it potentially later on. So what I'm doing is I'm creating a new cancellation token source every time I click this button so that I have a fresh token. Does that make sense? So let's see what happens when we do this. Okay, so we'll go ahead and run our application. And the first thing I'll do is we'll just let it run normally without requesting cancellation. There's our happy path. We see we get our data. So now I'll go ahead and click that. I'll click the cancel button. And now I see I have my operation was canceled. That's pretty cool, isn't it? And again, it's not that difficult once you figure out you need a cancellation token source. So let's do the same thing with our task button. So again, we'll come up here and get rid of our hard-coded cancellation token. And we'll use our token sources token. And then again, at the top of this, we'll go ahead and create a new instance of a cancellation token source so we get that fresh token. And when we do this, again, we'll click on the button. We'll get, we won't cancel. We'll get our happy path. And then we'll click on our button. We'll click cancel. And now we see that it says operation or cancellation requested, because that's the message we put up there. Now I want to show you one other thing that has to do with cancellation tokens. And this will be in our asynchronous method. Because in this case, I actually am using a lot of async calls. So this task.delay, this is obviously a task that we can await. I'm also using an HTTP client which has a getAsync method, and this is how we're fetching our data from our web API. This is awaitable, so this obviously also has a task. I also have a read as async down here when I'm reading the return data, and that's awaitable, so obviously I have a task there. Well, it turns out that as far as like all of the methods that are built in to the framework, most of them have an overload that takes a cancellation token as an additional parameter. So this task.delay, for example, in addition to the milliseconds that we have here, we can also use a time span. It also has milliseconds and a cancellation token. So I can actually pass in our cancellation token to this task.delay. And the effect on our application will be that the cancellation will happen immediately as soon as we click the button. We don't have to wait for that 3 seconds to go by. So we'll click Fetch with Task, I'll click the Cancel button, boom, pop up immediately. And at this point, we actually canceled the task.delay is what got canceled. Here's something that's a little more subtle. If I click my Fetch with Await and click Cancel, we get a different message. So the message that I got when I did that throw if cancellation requested, our message that came back in our exception was operation was canceled. But since I'm in a subtask, I have that task.delay that is now getting canceled. Instead, the message that's coming back says a task was canceled. So it's a little subtler, the message that's coming back. Now this is still an operation canceled exception. It's just that the message is different because the cancellation is coming from somewhere else in our asynchronous method. Complicated? Yes. Flexible? Extremely. So the good part about this is that we can handle pretty much any situation that we need. Again, if we need to chain methods together, we can chain methods together. If we want something that's let's just kind of overview what we have in both of these, because both of these, we don't really have a whole lot of code. You know, we have maybe 30 lines of code in each of these. So again, for our task, we're going ahead, we're kicking off our get method, our asynchronous method that returns our task. Then we have our continuation, where we're checking our status, ran to completion, canceled, or faulted, and doing the appropriate things there. And then we're re-enabling the button at the end of our continuation. If we look at our await method, again, about the same amount of code, but a bit easier to read because we don't have lambda expressions and nested generics and a bunch of cool stuff like that. But again, we'll go ahead and we'll await our get method, and that will get us our result. We can for each through that. It's in a try-catch block, so we can look for cancellation, we can look for faulted, and regardless of what happens, we can re-enable our button. Now, like I mentioned, there are situations where we're not allowed to use await. And that has to do with there's some synchronization contexts that it doesn't know what to do with. So it'll say, hey, you can't do that here. Like I mentioned, if we're on like a root level method, an entry point of an application, we can't flag that as async. So there's some situations where we'll need to resort to task because await is not allowed. And then there will also be situations where we want something a little more complex. I mean, this is pretty straightforward because it's just like our switch statement above. We have happy path, cancellation, exception. But we could have a situation again where we say, you know what? When this task is done, I want to kick off these 5 child tasks. And then we can choose what happens after that because there's a when all, which will say when all of these tasks are complete, go ahead and do this other continuation. Or I can just say when the first task is complete, start something else. Again, there's all kinds of stuff that we can do with this. There are a lot of options. We've looked at a little tiny bit. So most of the kind of standard day-to-day stuff we can do with await. But if we want to get into more detail, then sometimes we have to resort to using tasks directly. This is probably a really bad analogy because I don't know how familiar you are with LINQ, but LINQ, language integrated query, is one of my favorite things. And there's two ways of doing LINQ. We can do it with the query syntax that looks a lot like a SQL statement. From, in, join, group by, blah, blah, blah. Or we can use the fluent syntax where we dot the methods together.
And that's using the extension method.
Using the extension methods, yes. So there's two different syntaxes we can use. Now, when we use the query syntax, we're limited by the keywords that we can use because there really aren't that many keywords. But if we look at the extension methods, there's a lot of them. There's like 75 extension methods that we can do. So we can actually do a lot more when we use that fluent syntax where we're dotting the extension methods together than if we're using the query syntax. Now, there are ways where we wrap our query and say dot single or whatever, so we can combine them, but then your code gets kind of unreadable. And that was probably a really bad analogy because I don't know how many of you are familiar with LINQ. I love LINQ, by the way. So, and if you want to learn more about that, I have a video series on YouTube about LINQ, how to understand the extension method syntax and all that other fun stuff. So it's the same kind of thing. Await will work for a lot of our common situations, but if we do need to take full control, there's a lot of power. And again, just with the continue with method on task, there were 40 overloads. 40 overloads. And that's just that one method. And there's a lot of other methods as well. So let's just do a quick review of some of the gotchas that we've seen. And again, I don't want to tell you how long it took me to figure some of these things out. This one took me a while. So we do have properties on task: is completed, is canceled, is faulted. And again, these are true, false. They are not mutually exclusive, which is what I would assume. If I see three is's together, I'm going to kind of assume they're mutually exclusive. And again, is completed does not mean finished successfully. It means no longer running. But we do have the task status, which is an enum that has all of these cool different values that we can choose from, where we have canceled, faulted, and ran to completion, which does mean what it actually says. So we can use task status. And again, since they're mutually exclusive, we can use a switch statement. We can let it fill in based on the enum for us. It's really, really easy to use. And again, if we want to take full control, we can create separate continuations that use the task continuation options to say only on faulted, not on faulted, only on ran to completion, not on ran to completion, etc. So very flexible. When we're talking about cancellation, if you new up a cancellation token, again, it becomes unmodifiable at that point. So I can create a cancellation token that is in the cancellation requested state or one that is in the not cancellation requested state, but I'm not allowed to change it later on. What we want to do instead is use a cancellation token source, which is responsible for managing a cancellation token. So we just new it up. It has a token property that we can pass into our various methods, and it has a cancel method that we can call that will put it into a cancellation requested state. The other thing I need to create a slide for this is we looked at exceptions as well. And when we grab an exception off task, it is an aggregate exception. And we can use flatten on the aggregate exception to flatten that out into a single level rather than having the tree structure there. And so that's the whirlwind tour of task and await. And what I'm hoping is that await is no longer magical and task is really awesome. Again, it's very powerful, and we've looked at a very, very small percentage of what's out there. Just how to consume a method. We didn't really look at how to create our own asynchronous methods. And that's another topic. I could probably do a good 4 or 5 hours talking about that too. So if you do have any questions that come up later as this starts to sink in, feel free to send me an email. And again, the contact cards have my email address on them as well, so feel free to grab one of those. And then if you go out to my website, let me just show you the resources that are out there so you can get an idea. I have a local copy of my website because I never know where I have internet. And if you click on, right here we're in upcoming events. I actually spoke somewhere else last night. These are going to move off of the upcoming events tomorrow. But if you click on the demos link at the top, this actually has a list of everything that I've done for the last 6 years. So this is going to slowly move down, but it will stay here. And so if you click on the resources for this particular talk, then again, you'll get the slides. The code samples are on GitHub. There is a recording of me doing the 1-hour version of this presentation at NDC London, where I didn't talk about the extra continuation, so you guys got bonus material. This started out as a series of blog articles, so if you want to read the original articles, you can go through those. The articles, in addition to having the WPF application that I showed tonight, also show how to use this asynchronous stuff in a console application. You know, and like I mentioned, there's kind of some unique things there. And then I also have a video series, which is a screencast of basically all of the material that I showed you tonight. So if you want to go back and review, screencast is available. If you want to see me talking live like I did tonight, I have that recording available. And then I want to point out these guys, because I am not an expert on async. There are 2 people I know that are experts on async, and so I have links to them here. One is Stephen Cleary. So Stephen Cleary, he's written a couple books. He's written a bunch of articles in MSDN Magazine, plus a lot of other things. I would point to him as, I'm a developer who needs to use async. What are the common scenarios? He's really good at all of those. So I would highly recommend him. Lucian Wischik, he actually works for Microsoft. And I am convinced he is the only person who actually understands async in C#. I mean, he totally understands it. And what his stuff is good for is he will, for example, talk about the difference between having I/O-bound operations versus CPU-bound operations, and what types of asynchronous patterns you should use based on that. Because it's possible to take an I/O-bound operation, add a task to it, and actually make it slower. So Lucian Wischik is, again, he's a really nice guy, and he's really brilliant, and I'm pretty sure he's the only person on the planet who really understands this inside and out. So those are some options, and he's got a bunch of videos on Channel 9 and some blogs on the Microsoft blogs and so forth. So there's lots of stuff. And then I talked about Learn to Love Lambdas. So there's my materials on that, and link to. And then I also have materials on Get Funky, which is all about delegates, func, and action, since I mentioned those tonight. So if you want to brush up on all of those, that's out there. If you want to brush up on generics, I also have a series on generics as well. So pretty much anything you need, I've got out there. Are there any questions of stuff that I might have missed? Or I know that was the whirlwind tour, and you guys are probably just full at this point. OK, cool. Well, again, if you do have any questions that come up later, please feel free to drop me an email. And what I found is if one person has a question, probably more than one person has a question, so they usually turn into blog articles. So thank you very much for hanging out with me tonight. And hopefully I'll come back again in the future and talk about something else.
Yeah, thank you, man. That was crazy informative.
Or just crazy, one of the two.